on when the red light's on. Yeah, try that. Is that working? Try it now.
Does it work?
Yep.
Okay.
Yeah, good. Thank you.
Thank you. Thank you for the introduction, Fred, and thank you Liz for this presentation on the market route. I'm going to take a few steps back to talk about from analysis methods to quantitative image biomarker. Right, so before I do so, this is my disclosures. So first I will give you the motivation of this presentation and then give you an introduction of quantitative image biomarker. Then I'll focus on analysis method to the quantitative image biomarker. Then I will spend a few minutes on Kiva, quantitative image biomarker alliance, and finally I will draw the summary. So the motivation of this presentation, I have the opportunity to attend the previous Connect with Industry presentation here, and it was very exciting to learn the research work being doing here. And then, well, this is the work I've done years ago, so I developed some analysis methods to look at texture properties, and I then applied that to some mammograms that's in this database, and that work hasn't taken further than this because I finished my PhD. So today I'm going to talk about some of the things you can think about if you want to take your analysis method further. So back to the definition of quantitative image biomarker, as Liz has mentioned already, the QIB are objective characteristics derived from in vivo images as indicators of normal biological processes, pathogenic processes, or response to a therapeutic intervention. So of course, I will show you some images. So QIBs can be anatomical. So for example, in oncology, we'll be looking at tumor size. And recently, there has been work using radiomics to look further. So not just tumor size, look at different texture properties of the tumors. And in Alzheimer's disease, the size of hippocampus has always been one of the QIBs to look at, as this is associated with memory. And in neurological disorders, white matter lesions are shown in the images here. You can see there are some the white lesions, so-called the hyperintensity, and this is one of the quantitative image biomarkers as well. And not only anatomical, we can also look into functional. So for example, using dynamic contrast enhanced MRI, you'll be able to study the physiological aspects of the tumors. And then also, we can also look into the brain responses in a controlled experiment. For example, say memory test, and then we'll be able to image these brain signals. So as Lisa put it already, so analysis methods that can be lead to different categories of QIBs. So be looking at diagnostic, prognostic, and perhaps prediction whether this therapy is going to work or not, and then looking at the response to certain therapy, and also can be used for monitoring purpose as well. So this is going back to how do we go from there. So for example, you have a promising analysis methods, and you and your project team are very happy about it. What would be the next steps that you can then think about? So first of all, it's important to look into the technical performance assessments. So one thing to look at is accuracy bias. So for some cases, you might have the ground truth. If we go back to the oncology example, you might have the tumor that's being contoured by the radiologist already, so you can then compare your analysis methods with that. And also, how does your methods compare with others? And do you have any additional information? And then also, whether there's any application-specific fountain available that you can then verify your results. And I think also important is what is considered as outliers. As we know, medical imaging, there could be some noises, and it could be some scanning issues, so on. So not only analysis methods, perhaps you can add some quality control steps before your image going to your analysis pipeline. And for some analysis more complicated than the others, you have many steps. So you can then also put in some quality control in each steps to make sure that the value you got is so-called physical values. And once you are able to detect outlier, and also the question is how does your analysis methods handle those outliers, and also how precise you can actually do the quantification. So in terms of repeatability, whether there's any data for test retest. For example, you scan the same subjects on the same scanner on day 1, day 5, can you actually compare the results? And also that's relevant when your analysis method is not automatic. So for example, you have some human intervention into your analysis method, then perhaps you can have the analyst do the analysis, say day 1, and then a few days later they'll be doing the analysis again to check whether the values are similar or not. And then also consider reproducibility. So that will be you have the same experiments but in a different scanners on different days and with different operators where you were able to reproduce a similar result or not. Then also not just technical performances and the clinical validation. Can your biomarker demonstrate an association with the clinical endpoints or not? Well, simply back to the definition of QIB, it should be a measurable indicator of a pathological process, biological process, or response to an intervention. So I think there was a question about data in the morning, so here we just talk about bigger data. So after you have developed your methods, I think it's important to see whether you can actually apply that method to bigger data. For some projects, you probably have access to more data than the others. So you can then think about whether you can validate your algorithms using a wider range of relevant data. Say, for example, from different scanners, from a bigger cohort, or even from different cohorts, how robust your analysis method is. And of course, in the past 5-10 years, there have been a lot of open source data that researchers can access to. So for example, the mammogram database I mentioned before. So in this case, you have the clinical outcome, whether the tumors are benign or malignant, and there's also the region of interest that's being done by the radiologist that you can then check your segmentation with. And then if you're doing the lung CT lung imaging, there's also a database. And then if you're working in the Parkinson disease area, so there's some initiative. They have a lot of functional and also structural neuroimaging that research can use. And then recent UK Biobank study, so in the sub-study, 100,000 people will be scanned. So not only neuroimaging, there's also heart imaging, bone imaging, and artery as well. So all these are the open source data you have access to. Just as some example, there are many more out there. So in the last few minutes, I'm going to talk about KIBA. So KIBA is an initiative from ISNA, Radiological Society of North America. So their mission is to improve the value and the productivity of QIBs by reducing variability across device, patients, and time. So they do this by produce a description, so-called profile, I'll show you in a minute, so that you have the sufficient details to do the acquisition, analysis, and also interpretation of the results. So KIBA profile developments start with the public comment. So the KIBA community would then put the profile together first, and then the public can comment on that, say whether this was doing or not, and then it would then be used by several sites to make sure that the performance is good enough, or whether there's any feedback for the improvements. And finally, if that has been done by many sites, then many sites have performed a profile and demonstrate that the claim performance is widely achievable, and so that will then be published as a KIBA profile. So here I'll give an example. So this is one stage 3 technically confirmed profile for FDG PET as an imaging biomarker measuring response to cancer therapy. So this is one of the figures from the documentation. So you can see that so they give the detail on how you prepare your patients, and how the scan acquisition should be done, and followed by the imaging reconstruction, how should the image be reconstructed, and then the image analysis and also image interpretation for, to have the standard uptake value measurements. So that's also for the follow-up scans as well. And particularly, I think relevance for image analysis, so they give the detailed description of region of interest. How do you actually draw your region of interest in this case, and how do you compute the standard uptake value? So, well, there are many profiles out there, probably will be relevant to the research you are doing now. So in summary, the quantitative image biomarkers have been increasingly used in clinical trials and clinical practices, and the advances of QIB also rely on the analysis methods developments. The technical performance of QIB should be considered while you develop your analysis methods, whether you have access to more data, etc. And then also there are initiatives such as KIBA, they have profile set up that help to bridge analysis methods and QIB. So that's the end of my presentation.